Hello everyone, this is Rahul from RDS Bangalore team. Today we'll be covering the topic DB maintenance in PostgreSQL. Let's quickly move on to the agenda. So we'll be covering the short introduction to DB maintenance in PostgreSQL, and then we'll cover the different types of DB maintenance. We'll, we will not be going into depth in all types of DB maintenance as most of them are covered in the KNet videos. I would suggest you all to have a look at the KNet videos. They cover vacuum and auto vacuum in details. Although I'll be explaining all the DB maintenance activity briefly so that you have a connection while covering the KNet videos. Mainly in this video, we'll go more into reindexing, which is not covered in the KNet video. We will cover why we need reindexing and how reindexing is performed. We will also have a small demo how to reindex a index and under what circumstances we reindex mainly. In short, we will go through how data fragmentation happens in table and to defragment tables what is the use of vacuum and auto vacuum, and later we will wind up with the summaries we cover in this session. Let's move on quickly to the introduction to the maintenance activity. As we know, data in table are stored in data file pages and each page is 8 KB. Whenever an update or delete happens in table, the row does not get immediately removed from the disk page due to the concept of multi-version concurrency control, which is also known as MVCC. Actually, the row space becomes obsolete and cause fragmentation, or we can also call them bloating of the table and also for index too. Thus, to fragment them, there are tools called vacuum and auto vacuum which helps in regaining the space which was occupied by dead rows or tuples. The work the working concept of vacuum and auto vacuum are mostly covered in all the KNet videos in more details. So though you can reach me also for any clarification for vacuum or auto vacuum, but please go through all the KNet videos. Now let's quickly move on and see briefly the different maintenance activity in next slide. Here you can see the different maintenance tool which helps in defragmenting the data in PostgreSQL. They are mostly auto vacuum, vacuum, vacuum full, vacuum freeze, reindexing, and also there are a few other things which also affect in the maintenance. So let's cover a few little bit briefly about all these topics. Auto vacuum is a tool which automatically triggers when the threshold limit reaches according to the parameter set in PostgreSQL configuration file. Thus, it reclaims the space that were occupied by the dead tuples or the records for using them for the same table. Please note it do not let the space used by the other table. That is, it does not release the space to operating system. Vacuum is the same mechanism like auto vacuum, but it needs to be triggered manually, or we can schedule them in our cron jobs. We can also say as cron tab. We can run vacuum concurrently along with other transactions in DB, but it is advised to run them in the offline hours. Vacuum full helps in reclaiming the unused space so that other tables can use the space to write new records. It means it releases the space to be used by OS. The above topics are covered more in KNet videos, so I'm not going into depth. We will cover in more depth about the concept called reindexing. Reindexing is similar mechanism like vacuum, but reindex helps in regaining the unused space from the indexes. Before we understand more about reindexing, firstly we need to know more about fragmentation of data. Let's look into the next slide about it. So here there are two reasons or two factors which affect the data fragmentation. The first one is MBCC structure in Postgres, and the other one is ACID compliance. As we know, PostgreSQL follows MVCC. Therefore, whenever we insert any record and delete the record is not actually deleted. The record is marked obsoleted, and then those obsoleted records are deleted only during the DB maintenance activity like vacuum or auto vacuum. Therefore, regular maintenance is required to keep and check on the DB size. If you do not schedule the maintenance job, DB size is DB size will keep on increasing even though the DB size is not actual size of it. So, so we need a regular maintenance. And as PostgreSQL is ACID compliance RDBMS, so the rollback and commit are part of any transaction. Thus, PostgreSQL needs to be kept two copies at data at any point of transaction. Hence, it results in fragmentation of data. Let's move on to next slide and check on auto vacuum and vacuum. So I'll give a brief introduction because mostly it's covered in the Kenneth video, but you need to have a connection while you look into those videos in Kenneth. Auto vacuum is a tool which automatically triggers when the threshold limit reaches according to the parameters set in PostgreSQL configuration file. We have already seen that. Thus, it reclaims the space that were occupied by the dead tuples for reusing them in the same table. Keep in mind, it will be using in same table, not by the other table. Thus, it does not release the space to use by the other tables, and so it is called that the space is not released to OS. Vacuum is the same mechanism like auto vacuum, but it needs to be triggered manually, or we can schedule them in our jobs, daily jobs. But always we should have a maintenance activity, or else your database size will be increasing and it will be very difficult to control. Though your database is not actual 10 GB, but it will be showing 10 GB because of the dead tuples or the records. So it was a short description about auto vacuum and vacuum, and you can move on to the next topic, which is our main topic, that is called reindexing. So, like at times when there are fragmented index, we need to reindex them. So it comes in mind what reindex does. In short, it rebuilds an index using the data stored in the index table by replacing the old copy of the index. Now, when reindex is clear for us, it comes in mind when we need to reindex the index. So, mainly when an index has become blotted, meaning it contains many empty or nearly empty pages, uh, so that time we need to reindex. Any other scenario is like when you have altered a storage parameter such as fill factor for an index, that time also we need to reindex. Or else other scenario is like when an index build with concurrently option, sometime it fails, leaving an invalid index. That time also we need to reindex. And lastly, when an index has become corrupted and no longer contains valid data, that time also we need to reindex. So reindex can be done in index level, table level, database level, and also in system level. It is very important to reindex system dictionaries using system level because that is mostly ignored by most of the people. So that is why we should always also reindex the system dictionaries because it is very important for the query planning. We should reindex at least once in a week depending on the load of transaction. Load in the sense there are more transaction in terms of insert, delete, update, and there are lots of use of indexes. In such a scenario, it should be regularly reindexed to get better performance of queries. So reindex, what happens in background? Like it is similar to drop and recreate of the index, and the index contents are rebuilt from scratch. So that is why it's very important, because it become blotted and you need to reindex them always. So, but reindex will lock out the write. You cannot lock anything, but it will help. But it will allow the reads. And also reindex a single index or table requires being a owner of that index. That is for sure. And reindexing a database requires being the owner of that database. But if you are doing in community Postgres, you can do all the work using the super user. So now when you have seen what is reindex and other thing, so we should understand more details. So for that, I thought of going for a small demo. So it will help in understanding more. Uh, so I have a table named new inside Postgres database, and the index I have created is index 1 on the ID field, and I perform lots of transaction, insert, update, delete, so so that there is lots of mm, blotted in the index. Then after performing all the insert, update and delete, index 1 got blotted. I'll show you how it is blotted. Then I'll like we can verify it using a customized query, like your index, which index is more blotted. Then at last we perform a reindex. So I'll show you. I'll go to my terminal. So here is a terminal. So I have ran lots of. You can see I have ran lots of insert, delete. So I run all those stuffs. Now you can see which I'm in Postgres database. Current, I can see. I'll show you my current user. Sorry, it is Postgres is my master user. Postgres is my master user. So I'm connected to RDS instance, not an community Postgres. So I have blotted. I am using this new table owned by Postgres, and I'll see how that table looks like. It is having index 1 and in the column ID. So as I have run lots of insert, update and delete, so I have a customized query. So I'll be running that query to show you that uh, which column will show you what and all. So for that I have that query written. I'll just go to that query. So I need to go down. Here is that record. Here you can see my current database is Postgres, schema name is public, table name is new, index name is index1. The real size is the real size value is this much, but extra size is this. So these are the extra which is been occupied, but it is not actually occupied by the database. Sorry, by the table. So these are the extra space that should be released from this table so that it can be reused. So the ratio is 10%. 10% of the space is like it has been wasted. Then the plot size is like this is the plot size. How much is the plot size and the ratio? So this is how we figure out like this percent should be as low as 0. That means you need not reindex any of your indexes. If this ratio is like going more and more, you can you need that's the time you need to reindex. Don't worry, I'll give you that query. I'll give you the link where I got that query. I got it from one of the wiki link of Postgres. So I'll be giving you that query also. You can see that link. So first of all I'll show you by doing reindexing, and we'll see what is the result of this. So I'll be reindexing this table, or you can specifically reindex this index. So I'll do that table itself. So reindex already. So it is reindexing is happening in background, as I said. So what it does in background, it drops and recreates. At this point of time, no write can happen on this table called new, but read can happen. So maybe you need to wait because that's a very big index. It might take some time. Meanwhile, let's check if you can write something in this or you can read something. So I have opened one more terminal. So this is that table. So let's try to read something from this table. Select star from new limit 1. Because reindex have taken all the memories, so the select have become slow here because it's consuming all the memories. So I've cancelled that query. Also, if you try to write something, uh, insert into new one, it won't be writing because the table have got busy. But after some point of time, you can see when the index will be revealed, you can see like you can see the changes here. Now there's so much of plot and the table size is huge. Let's see from here, it is close to 10 GB. Table size is 10 GB, but the associated index might be less size. Uh, but after reindex, you can see the changes. So it will take some time. Let's wait. It's here and the size is 12 GB. So let's wait till the reindex is done and we'll see the result. So after this is done, the result should be quite similar to I have already done it before for my testing purpose. So it should be similar to, no, this is also blotted one. The query is very big. It's well written by one of our folks. I guess it's not there, but let me have a try. Let me give a try if I can find out that result. So yeah, so after index is done, it will be quite similar to like this. Like real size is with this, the real exact size of the index. Then extra size is 0 because it's not blotted, and other things all at 0 because nothing is blotted. Because this happened after I have ran a command reindex. So if you're lucky, you will be able to see that command when it ran. So no, but it's like simply it will come like reindex. It will take some time, but this command which does work. You can give in the instead of table, you can give the specific index name. So this command works generally. It's taking time for me because the table size is close to 10 GB. Let's move on to the other thing. Like let's wind up with the summary. So that's all I had with my like demo part. So the link from where I got the query, I'll show you, is this link. So it's a link from where I got the query. So So we have seen the demo. So in a summary, we have covered like regular maintenance activity. We have covered so that you can have a so that you can control the size of the DB. Like regular maintenance activity are required so that you can control the size of the DB, so that it don't get bigger with dead tuples. Tuples is nothing but the records. Vacuum and auto vacuum reclaim space from dead tuples to be used by same tables. Then reindex reclaim space from blotted indexes. So these all are the things we have covered, and also we have covered a small demo. So with this, we came to an end of this video. So I hope the session was informative and it would be helpful for you for any cases. Feel free to reach me for any other concerns, query. My alias is RSSAH. Thank you.